In this video, I'll be going through a GCSE Higher Exam from 2018. This is paper 2, started on the 7th of June for the Edexcel specification. And as always, paper 2 is a calculator paper. Okay, let's get into the questions then. Question 1 is about indices or powers. And for this, you need to know your index laws. Well, it's going to help you in terms of getting to the answers quickly. You could always write this in extended form, so m to the power 3 is like m multiplied by m multiplied by m, and this is multiplied by m to the power 4, which is m multiplied by m multiplied by m multiplied by m, and then you see, well, this is m times itself 7 times, which is m to the power 7, but if you know your index laws, you can jump straight to this answer of m to the power 7 by seeing that we can add the powers. So m to the power 3 multiplied by m to the power 4, we add those powers and we get a final answer of m to the power 7. Part B says simplify 5np cubed, all cubed. For this, we distribute that power outside of the brackets to all of the terms inside the brackets. So we'll have 5 cubed, which is 125, n cubed, which is just n cubed, and p cubed cubed. And this is another index law that's going to help you here. So p cubed cubed is like saying p cubed multiplied by p cubed multiplied by p cubed. And similar to part A, we would add the indices there. So this would be 3 plus 3 plus 3, which is p to the power 9. But if you know your index laws, you know that if you have some power and you raise that to another power, you just multiply those indices. So 3 times 3 will give you p to the power 9. So final answer there is 125 n cubed p to the power 9. Part C says simplify 32q to the power 9 r to the power 4 over 4q cubed multiplied by r. For this, you need to know that when you are dividing numbers with the same base, so here we have a q to the power of something and a q to the power of something in the denominator. When you have that same base, you can subtract the powers. And for the numbers, we just do regular division. So 32 divided by 4 is 8. Q to the power 9 divided by q to the power 3, we do 9 take 3, so it's q to the power 6. And then r to the power 4 divided by r to the power of 1. If there's no power, you just assume that it's 1. So r to the power 4 divided by r to the power 1 is 4 take 1, which is r cubed, r to the power 3. So that's the final answer there. And that was question 1 for 5 marks. On to question 2. Question 2 says, part A says, find the lowest common multiple of 40 and 56. For lowest common multiples and highest common factors, you can break the numbers into their prime factors. I would argue this is the most efficient method because it will always give you the correct answer. There's basically no other method that you need if you know how to do it this way, and there's no kind of trial and error or anything like that. So once you learn this way, that's all you need for lowest common multiple and highest common factor. So 40 is 2 cubed times 5, 8 times 5, right? 56, we could think of that as 8 times 7, so 2 cubed multiplied by 7. And the lowest common multiple of 40 and 56 is we take the highest power of each prime factor. So 2 to the power cubed is in 40 and 2 to the power cubed is in 56. 3 is the highest power there. Well, it's the same in both. But if we had, say, 2 to the power 4 over here, we would use 2 to the power 4 in the lowest common multiple. So 2 to the power 3 is in the lowest common multiple, and we multiply it by the other prime factors. So 5 to the power 1 is in 40. There's no 5 over here, so we take 5 to the power 1, and that belongs in the lowest common multiple. And then we have 7 to the power 1 over here, no 7's over here, so 7 is in the lowest common multiple as well. So you take the prime factors with the highest powers from each number. I like to think of it as like a battle, so the number with the highest power wins and it gets into the lowest common multiple. But however you want to think about that is fine. And then you work this out and you get your answer. So 8 times 5 is 40, and then multiplied by 7. 4 times 7 is 28. So 40 times 7 is 280. And that's our answer. 280 is our lowest common multiple. Okay, on to part B. part B says A equals 2 cubed multiplied by 3 multiplied by 5, and B equals 2 squared multiplied by 3 multiplied by 5 squared, write down the highest common factor of A and B. For the highest common factor, we take the prime factors that are common to both numbers, so with the same power. So we have a 2 squared in B and a 2 cubed in A. That means there's a 2 squared in both numbers, right? There's a 2 squared hidden in this 2 cubed. 2 cubed you could also write as 2 squared multiplied by 2 to the power 1. So there's a 2 squared in A, so we take that as belonging in the highest common factor. So we can say the highest common factor for A and B is going to have a 2 squared, and then we multiply that by the other prime factors that are in these numbers. We have a 3 in B and a 3 in A, so that belongs in the highest common factor. And then we have a 5 and a 5 squared. And again, take the one that's common to both. So 5 to the power 1 is in both numbers, so again, that's going in the highest common factor. So this is kind of like the opposite of the lowest common multiple. In this case, the one with the lowest power gets in, as long as it belongs to both numbers. If we had like a multiplied by 7 here, because it's not in A, we would not have that 7 in this highest common factor. Okay, so then we multiply these together and we have our answer. So 2 squared is 4, 4 times 3 is 12, multiplied by 5, 12 times 5 is 60. So our highest common factor is 60 for these two numbers. And it's interesting that you can come up with that even though you don't actually need to work out what A and B actually are. Of course you could work them out, but you don't need to. Okay, so that was question 2 for 3 marks. On to question 3. Question 3 says the line L is shown on the grid. Okay, here we have our grid with the line. Find an equation for L. Okay, this is a key skill in GCSEs. You need to be able to find the equation of a line from a diagram or from a graph. The first thing that I notice is the y-intercept is -6. So that's part of the equation, and then I also need the gradient. So the gradient, remember, is the rise over the run. So let's write that down. Gradient equals rise over run. And the rise is, if you pick a point on that line, let's start at -6, you go up until the line hits another intersection point of the graph lines. That's going to make it easier. If you pick this point, well, okay, I've gone up 2, but then how much have I gone across? It's not clear. So you want to pick a point where the line goes through the graph lines to make it easier on yourself. So the rise from -6 to -3 is 3. I've gone up 3. And the run is how far we go across. So we go up to -3, across to 1 on the x-axis, and we started at 0, right? So the y-axis is at 0 on the x-axis. So our run, how far we've gone across here, is 1. So rise over run gives us the gradient, that's 3. And now we have enough information to write down the equation for L. So remember that y equals mx plus c, m being the gradient, and c being the y-intercept, where the graph cuts the y-axis. And then we can say, well, the gradient is 3, so we'll have y equal to 3x take 6. -6 was the y-intercept, and that's our equation of our line. So final answer, y equals 3x take 6. And that was question 3 for 3 marks. On to question 4. Question 4 says Raya buys a van for £8,500 plus VAT at 20%. Raya pays a deposit for the van. She then pays the rest of the cost in 12 equal payments of £531.25 each month. Find the ratio of the deposit Raya pays to the total of the 12 equal payments. Give your answer in its simplest form. Okay, a couple of things we have to work out here. We have to work out the cost of the van because they've told us that it's 8,500 plus the 20%. So we need to work out what 8,500 plus 20% is. And then we have to work out how much she paid in those 12 equal payments. So 12 times this number. And then we can work out the deposit. And then we have to work out the ratio. So firstly, let's work this out, the total cost of the van. So we're going to do 120% of 8,500. This is one way to do it. You could also find 20% and add that on. But when it's a calculator paper, I would suggest doing it this way, because then you can use something called a multiplier. So if you're working out a percentage of an amount with a calculator, you can use a multiplier. The multiplier for 120% is 1.2. So you basically just take that percentage and divide it by 100. That gives you your multiplier. And then we do the multiplier multiplied by the amount. So 1.2 times 8,500, and that gives us 120%, or 8,500 plus 20%. Okay, so 1.2 multiplied by 8,500, that gives me £10,200 for the total cost of the van. So now let's work out how much he paid in those 12 equal payments. So we're going to do 12 multiplied by 531.25, and isn't it just great? We have a calculator for this, so we don't have to work it out by hand, and we get £6,375. And now we can work out the deposit, which we didn't know originally. So she paid this much. If the total cost was this much, she must have paid a deposit of 10,200 subtract her payments. So 10,200 subtract 6,375. Again, going to the calculator, 10,200 take 6,375, and we get 3,825. And that's the deposit. So we should say, okay, so this is the deposit paid, and then we need the ratio of the deposit to the total, to the 12 equal payments. So we're going to say the deposit to the payments, this is in the ratio of 3,825 to 6,375, and then we need to simplify that because it says give your answer in simplest form. There's a couple ways you could simplify this. You could just kind of do trial and error and think, okay, what numbers would go into both? So 5 would be an obvious one, divide by 5, and then divide by whatever else is common between those. A bit of a shortcut here is to divide the two numbers. So do 3,825 divided by, whoops, that's a multiply, divide by 6,375, and that's going to give you a decimal, which you can then convert to a fraction. And this will look different on your calculator. For mine, I have to go to this menu and then go fraction, and that gives me the fraction 3/5, which is the same as a ratio of 3 to 5. So there's a bit of a shortcut with a calculator. Divide the two numbers and then convert the decimal to a fraction. So I know then that this simplified ratio is going to be 3 to 5. Okay, so that was question 4 for a total of 5 marks. So we just have to write down our final answer, 3 to 5, and we are done. Okay, on to question 5. Question 5 says, part A says complete the table of values for y equals x squared take x take 6. Okay, for a table of values, we want to take the x value and plug it into the equation. So they've done one for us, or they've done two for us. -3 squared take -3 take 6 will give you 6. So -2 squared is 4. Take 2, and for this, I think it's useful to have some scratch notes over here just to make some rough notes to yourself, just to make sure you don't make any mistakes. So you've got -2 squared, which was 4, and then we subtract -2. So I'm substituting this value into this equation, and then I take 6. So this is going to be 4 plus 2 take 6. That's 6 take 6, which is 0. And then -1 squared is 1. Take -1 take 6. This is going to be 1 plus 1 take 6. So that's 2 take 6. That'll be -4. And then plugging 1 in. And you can rub these out as you go if you like. It doesn't really matter. You don't need these for the marks. So 1 squared take 1 take 6. That's going to be 0. Take 6. That's -6. And then 2 squared is 4 take 2 take 6. That's 2 take 6. That's -4 again. And then 3 squared is 9. Take 3 take 6. That's 6. Subtract 6. That's 0. Okay, so we have our table of values, and we are done for part A. Part B says on the grid, draw the graph of y equals x squared takes x takes 6 for the values of x from -3 to 3. Well, we have our table of values now. We need to plot these points on the graph and then draw our graph in. So the first point will be at -3, 6. Let's go down to the graph. We have -3 on the x-axis and was it +6 on the y-axis. So that point is going to be here. Then we had -2, 0. So -2 on the x-axis, 0 on the y-axis. Then we had -1, -4, which is down here. Then we had 0, -6, 0 on the x-axis, -6 on the y-axis. Then we had 1, -6, and then we had 2, -4, and the final point, 3, 0. Okay. So now comes the hard part of sketching the graph. So I'm going to try to do this as neatly as possible. And I would suggest doing this with a pencil on the actual exam, doing it with a pencil, sketching it with the pencil, and then possibly going over it with a pen or just kind of neatening it up once you've sketched it in. So you get a nice neat graph. Oops, so I've made a mistake there. Clearly it needs to dip down below -6. So you need to sort of anticipate how it's going to look. So it's going to look like something like this. Okay, and then connect up the other side. And okay, not too bad, not too bad. And this is the graph of y equals x squared take x take 6. Okay, so we've sketched our graph in. Part C says use your graph to find the estimates of the solution to the equation x squared take x take 6 equals -2. So what this is saying is this is our graph we've just drawn, and this is a line, this is a horizontal line at -2. So we need to draw in a negative line at -2, and I might just use a different color. So let's use red and draw a horizontal line at -2. Okay, there we go. All right, I just need to move that down a little bit. It's being a bit funny. Okay, I can't get exactly on the line for some reason, but you get the idea. And then the solutions are where this horizontal line and the graph cut, so where they intersect. And you'll get 2 points there. Okay, this one looks fairly clearly like it's on 2.5 on the x-axis. And just to be clear, we are looking for solutions for x, right? This equation is in terms of x. That's the unknown, so we're looking for solutions for x. And this one here is at about, well, this is -1.5, and each little line is 0.1, so this will be about -1.6. Okay. So my two solutions for x there are going to be, or we could say x equals 2.5 and -1.6. You don't even really need the x equals, you could just write those two numbers there. Okay, so that was part C, and question 5 for a total of 6 marks. Question 6 says a force of 70 newtons acts on an area of 20 centimeters squared. The force is increased by 10 newtons, the area is increased by 10 centimeters squared. Helen says the pressure decreases by less than 20%. Is Helen correct? You must show how you get your answer. They also give us this equation, pressure equals force on area. For this question, I would work out the pressure before the changes and then after the changes, and then find the percentage increase or decrease. So for the first situation, when we have 70 newtons and an area of 20 centimeters squared, we can work out the pressure. So the pressure is going to be force on area, that's 70 on 20. And let's get a decimal answer for that. So 70 on 20. I guess you could also just use fractions, but seeing as we have calculators, we might as well use decimals here. So the pressure in the first situation is 3.5 newtons per centimeter squared. For the second situation, let's call that P2 for the second pressure. we have the force is increased by 10 newtons, so we would have a force of 80, and the area is increased by 10 centimeters squared, so we would have an area of 30. Now we have a pressure of 80 on 30. Again, let's get a decimal, although this is going to be recurring, but that's fine. So 2.6 recurring, and that's newtons per centimeter squared again. And now we have the difference, so we can see that the pressure has decreased from 3.5 to 2.6 recurring, but we need that as a percentage of the original pressure. That's what this is talking about, this percentage. That's always in terms of the original amount that you're starting with. So firstly, we want the difference, so we want to do 3.5 take 2.6 recurring and divide that by the original pressure of 3.5. That's going to give us the ratio of the difference to the original pressure, and then if we multiply that by 100, we will get a percentage. So now let's put that into a calculator. So we've got 3.5 subtract 2.666. Okay, I've forgotten how to put recurring decimals into a calculator. If you know how to do that, of course use the recurring decimal function on your calculator, but this will get us a decent enough answer. So we get 0.83, and then divide that by the original pressure, 3.5, and multiply by 100, and we get a percentage decrease of 23.8%. So approximately, rounded off, this is 23.8% percentage decrease. So Helen said the percentage decreases by less than 20%. Clearly she's incorrect. Okay, so just to finish off, I would state that. So Helen is incorrect. Incorrect. The pressure decrease is approximately 23.8%. Okay, definitely not less than 20%. That was question 6 for 3 marks. Question 7 gives us a diagram with a shape, and it says enlarge shape A by scale factor 1/3 with center 0, 1. This is a fairly straightforward question as long as you know how to enlarge shapes by a scale factor with a center of enlargement, then you should be fine here. So the first thing you need to do is to connect the vertices of the shape to the center of enlargement, and they've marked it on here on the graph 0, 1. And well, you can see this line here is kind of going through itself. So connect that center of enlargement to the vertices, and then with this scale factor of 1/3, you want to basically divide this length by 3 and then take one part of it. So the ratio of the distance from the center of enlargement to the vertices of the two shapes is going to be in the ratio of 1 to 3. So if we look at this line here, it conveniently goes through the grid lines at 3 points. Okay, so that's fairly easy to divide in 3. Another way to do this is just to look at the vertical distances and the horizontal distances and divide those. So from 1 to 10, that's the distance of 9. Dividing that by 3, we get these values here, 4, 7, and 10. Okay, 9 divided by 3, you get 3 equal parts. And then if we look at the horizontal distance from 0 to 3, dividing that by 3, we get these two values. And we want to use one part of that. So going up to the first kind of division, and then across to the first division in the horizontal direction, we get our first corner of our shape. Okay, so again, just to reiterate, divide that line by 3, and if it's a scale factor of 1/3, you use one part of that line. Then for the other vertex, let's look at this corner here. Looking at this line, we want to divide that by 3. Again, it goes through these 3 intersection points. So this is going to be my second corner of my shape. For this corner here, we had this line. Again, it's going through these intersection points. So we're going to use this corner here. So we've got 3 corners already, and actually I've accidentally already drawn in the 4th corner. If we look at this line from this corner to the center of enlargement, well, if we want to divide that by 3, let's do it the other way. We go from 1 to 7, that's 6. Each second grid line would be we're dividing it by 3. So go up to 3 and across. If we go across from 0 to 6, divide that by 3, we get 2. So up 2, across 2, and we get our 4 corners of our shape. Let's draw it in now. And we are done. And just to make it clear that you know where the shape is, make sure you shade it in, because sometimes it can look confusing as to where your shape actually is on the diagram. So we could just look at, say, what if it said a scale factor of a half? In that case, you want to divide these distances by 2, and that's a little bit more difficult in this example because for this corner we've gone up 9. 9 divided by 2 is 4.5, so that would be at 5.5 because we're starting at 1, so that would be in here if we're enlarging it by a scale factor of a half. And then for this line, we went up 9, so it would be here approximately, and always your corners are going to be on these lines, these construction lines that you draw. So if you get like a corner and somehow you think it's over here somewhere, you know it's wrong because it's not on the construction line. So that's kind of another sort of a shortcut. So again, this was just if we're enlarging it by a scale factor of a half, just to give another example of how to do this type of thing, a bit quicker maybe. So that would be half, but this is a third. So that would be my final answer there for question 7 for 2 marks. And your drawing is your answer there. Another thing to look out for on these types of questions is sometimes they'll say label the shape, B or something. So always make sure if it says that to label it. It doesn't say it in this case, so I just shade it in for that question. Okay, on to question 8 then. All right, question 8 says 60 people were asked if they prefer to go on holiday in Britain or Spain or Italy. 38 of the people were male. 11 of the 32 people who said Britain were female. 8 males said Italy. 12 people said Spain. One of the females is chosen at random. What is the probability that this female said Spain? This is the type of question that wants you to draw a Venn diagram. In this case, there would be 3 circles for Britain and Spain and Italy. But we can also just do it using arithmetic. So firstly, let's summarize the information they've told us. So we've got 60 people in total. 38 of them are male. So we've got male 38. That means how many are female? We can work that out. 60 take 32 is 20. 60 take 38, sorry, is 22. So then they also tell us that 8 of the males said Italy. So let's just make a bit of a tally. We've got 8 males that said Italy. We have 12 people said Spain. 12 people said Spain. Can we work out how many of those were male or female? Well, for this we might need this piece of information. So for Britain, they tell us that 32 people, of the 32 people who said Britain, 11 of them were female. So we had 32 people that said Britain, 11 were female. That means that 32 take 11 would be the number of males that said Britain. So that would be 21. So 32 take 11 is 21 males. And we can put this information together to work out the number of males that said Spain, because we've got 28 males said Britain, 8 males that said Italy. So 21 plus 8 is 29. That leaves us with 38 take 29. That's 9 males that would say Spain. Now if 12 people in total chose Spain, that means that 3 females must have chosen Spain. And then we can work out the number of females that said Italy, because we have 11 females choosing Britain, 3 females choosing Spain, that's 14, 22 in total. That leaves us with 22 take 14 is 8 females that chose Italy. But we didn't really need that piece of information, because the question is, what is the probability that this female said Spain? So this is the piece of information we needed. 3 females chose Spain. If there are 22 females in total, the probability that one of them would choose Spain will be 3 out of 22. So let's just write down the probability that a female chose Spain is equal to 3 on 22. So that would be my final answer there, 3 out of 22 for question 8 for 4 marks. So a little bit of problem solving there, a little bit of arithmetic just to get that number there. On to question 9. Question 9 says Jean invests £12,000 in an account paying compound interest for 2 years. In the first year, the rate of interest is X%. At the end of the first year, the value of Jean's investment is £12,336. In the second year, the rate of interest is X on 2%. What is the value of Jean's investment at the end of 2 years? So in the first year, we have an interest rate, and then in the second year, that interest rate halves. So we can work out X based on this information. By how much the amount in the account is increased. For this, it helps to know how to find a percentage increase. This is where you take the difference between the two amounts. So we'll do 12,336, take 12,000. You don't really need to write that down. You can see that that's 336, but this is just to make it clear how we're getting this answer. So you take that difference and then divide it by the original amount. And that's how you're finding a percentage increase. That's a useful skill for GCSEs. So you take the difference, divide it by the amount, and then multiply it by 100. And we'll get our percentage increase. This is going to be the same as the interest rate. So let's do 336 divided by 12,000 and multiply by 100. We get 2.8. 2.8% is a percentage increase, which is of course the same as the interest rate. Okay, so we have an interest rate in the first year of 2.8%. In the second year, it's X on 2, so 2.8 divided by 2, that's 1.4. So that's our interest rate for the second year. And the question is, what is the value of Jean's investment at the end of 2 years? Well, we need to take this amount and increase it by 1.4%. I would suggest converting this to a decimal to do this, so we can do 12,336 multiplied by 1.4% as a decimal is 0.014, and then we'll get our answer. So 12,336 multiplied by 0.014, and I get, oh, that will be the interest, and then I actually need to add that on. So 12,336 plus that interest will give me my final amount. A shortcut to that is what I should have done is you can multiply this by 1.014, and that will give you the amount plus the interest automatically. So that's the way I should have done it. So final answer there, 12,508.704, 12,508.704 pounds, and I don't think there's any need to round that off. So final answer, 12,508.704. Okay, that was question 9 for 4 marks. On to question 10. Question 10 says the vector A and the vector B are shown on the grid. On the grid, draw and label vector negative 2A. Negative 2A is going to be in the opposite direction of A, and it doesn't matter where you draw vectors. That's something cool about vectors. They are not dependent on where they are positioned. It's more about their size and their direction that's important. So we can draw this really anywhere. Let's just draw it here. So we know that it goes down 2 and across 1. That would be negative A, but we want negative 2A, so we double the size of that vector, and then make sure to indicate the direction. It would be going in this direction. So that is negative 2A there. Part B says work out A plus 2B as a column vector. For this, you could draw the vectors in, so you could look at A and then add 2B. So B is down 3 and across 1. So if we joined that up here, we go down 3 and across 1, that would be here. But we need 2B, so we do that again. So that would be 2B, and it's in the same direction as B. And if you're doing a plus 2b, you want from the start of a to the end of 2b. That's your, that's the journey you've taken to do a plus 2b. Up a and down 2b, this is your start point, this is your end point. So the journey, the shortest distance between those 2 points is your answer. So from this point, we go down 4, and well, we should talk about across because that's usually the first number you write. So we go across 3 and down 4. Okay, so across 3 is a positive 3 in a column vector, and down 4 is a negative 4. Another way to do this is to look at the vectors and change them into column vectors. So A is across 1 and up 2, that would be 1, 2. And then B, 2b would be 2 lots of b, which is across 1 and down 3, so that's 1, negative 3. This equals 1, oops, not a fraction. This is 1, 2 plus 2, negative 6. 1 plus 2 is 3. 2 take 6 is negative 4. Okay, so maybe that's a bit of a longer method. Maybe drawing it is easier, but that's possibly a way to double check. I don't know. But there you go, that's a different way of doing it just with column vectors. Okay, that was question 10 for 3 marks. Question 11 says f and g are functions such that f of x equals 2 on x squared and g of x equals 4x cubed. Find f of negative 5. So this is saying, well, if the input is negative 5, what is the value of the function? So you take this function, 2 on x squared, and you put negative 5 in where the x is here. Okay, that's our input. So we're doing 2 on negative 5 squared, which is 2 on negative 5 squared is positive 25. So that would be my final answer there, 2 on 25. Part B says find f of g of 1. This is what we call a composite function. First you need to find g of 1. That's saying what is the value of g of x when x is 1. So putting 1 in here. Let's write this down. G of 1 is 4 multiplied by 1 cubed. 1 cubed is 1, so this is 4. And then we want f of this value, the value of g of 1, so f of 4. Inputting 4 into the function f of x, we get 2 on 4 squared, which is 2 on 16. And you can simplify that. That is 1 on 8, the common factor there being 2. So final answer there for f of g of 1, 1 on 8. If you would like more on functions and composite functions, check out my video going through lots of different examples of composite functions. On to question 12. Question 12 gives us a bunch of graphs, and it says the graphs of y against x represent 4 different types of proportionality. Match each type of proportionality in the table to the correct graph. So here we have the types of proportionality. The first one is y directly proportional to x. This is a linear relationship. So this is saying for each increase in x, y is increasing by the same amount. Not by the same amount as x, but by the same amount each time. So an example of this might be y equals 4x. So for each increase in x, each unit increase in x, y is increasing by 4. So it'll be the same increase in y each time. So this is a linear relationship. That is graph B. Okay, so we put a B in here. The next one is y directly proportional to x squared. This is a quadratic. Hopefully you know what the graph of a quadratic looks like. That will be graph D here. So we put a D in here in our table. The next one is y proportional to the square root of x. The way I think about this is it's a reflection of the quadratic. So you could square both sides here and you would have x proportional to y squared. So it's like a reflection of a quadratic, and it looks like a sideways quadratic like this, like graph A. So then you're kind of turning this graph on its side. The y-axis is now what we had as the x-axis down here, and then x is like the y-axis here. So that's why it looks like this quadratic graph just on its side. So for the third one there, we've got graph A. And then the last one is y proportional to 1 on x, or another way of saying this is y inversely proportional to x. This is saying that as x increases, y decreases, and vice versa. So as x decreases, y will increase. And well, by process of elimination, we're left with graph C, but we can also see this is correct because as the x values get larger, y is getting smaller, and as the x values get smaller, the y values are getting larger, just as we would expect with an inverse proportion. So the last one there is graph C, and that was question 12 for a total of 2 marks. Question 13 gives us a diagram and it says A, B, C, and D are points on the circumference of a circle, center O. FD is a tangent to the circle. Part A says show that y take x equals 90. You must give a reason for each stage of your working. Okay, so y is in here, x is here, and we need to show the difference between those is 90 degrees. The starting point for me in this question was to look at what they're asking me to show. So they're asking me to show there's a 90-degree angle in here somewhere. So I began by looking for a 90-degree angle in this diagram. Can you see where there might be 90 degrees? And actually the only place where I saw a 90-degree angle was in here between the tangent and the radius. That's one of the circle theorems you need to know. We're going to be using circle theorems for our answer here. One of the circle theorems says that the angle between a tangent and the radius is 90 degrees. So in here, we have a 90-degree angle. So that's where I'm going to start. So I can say that the angle EDO, angle or ODE, either way, ODE equals 90 degrees. And this is the tangent radius theorem, the angle between the tangent and a radius. By the way, if you want the proof of this theorem or any of the other circle theorems, check out my video on the proofs of all the circle theorems you need to know for GCSEs. Anyways, to continue, what I want to do now is to show that looking at this angle in here, this one BDE, let me use a different color, this one in here, between this line and the tangent, that is 90 plus x. And if I can show this angle equals y, then I will actually have shown y take x equals 90. So this entire angle is 90 plus x, and I can actually prove this also equals angle y using another circle theorem. This is what we call the alternate segment theorem, and I'll get a highlighter out for this one. So a segment of a circle is basically when you divide the circle in two parts. It doesn't have to be two equal parts, it can be any part. So as long as you draw a line across a circle, you have created two segments. So in this case, looking at this line BD, we have a segment here on this side of the line BD. Okay, so that's one segment on this side of the line BD. The other segment is over here. Okay, hopefully the colors are not too overwhelming. So here I have my two segments, one in orange, one in yellow. You can see this angle is in this orange segment, and this angle Y is in the yellow segment. And it turns out this angle in the orange segment between the tangent and BD is equal to y. This is called the alternate segment theorem because these angles are in alternate segments. This one's in the orange segment, this one's in the yellow segment. This always works when you have a tangent and a triangle inside the circle. So the angle in the alternate segment is equal to the angle between the tangent and the triangle in the other segment. Okay, hopefully that makes sense. Anyways, we showed this angle is equal to x plus 90. We also showed it equals y. So let's go and firstly write that down. We can say that angle BDE is equal to y. This is the alternate segment theorem. Alternate segment theorem. And then, therefore, y equals x plus 90. Therefore, y take x equals 90. Okay, so that should be enough for the 3 marks there for part A. Part B says Dylan was asked to give some possible values for x and y. He said y could be 200 and x could be 110 because 200 take 110 equals 90. Is Dylan correct? You must give a reason for your answer. So could y be 200 degrees? Well, looking at this diagram, hopefully you can see that no, y cannot be 200 degrees for 2 reasons. One, it's inside a triangle and we know the angles in a triangle add up to 180. Also, y is on a straight line, and again the angles on a straight line add up to 180. So you could use either of those. Let's go with the triangle. So we can say y cannot equal 200 as it must be less than 180 degrees because of angles in a triangle. So because angles in a triangle add to 180. Also, as I said, you can use the fact that angles on a straight line add to 180. And that was part B for 1 mark and question 13 for 4 marks. Question 14 says the distance time graph shows information about part of a car journey. Use the graph to estimate the speed of the car at time 5 seconds. Okay, so at time 5 seconds, that would be here. So we want the speed at that time. For these types of questions, what you want to do is draw a tangent to the graph at that point. This can sometimes be a bit tricky because it's hard to see exactly what the tangent should look like. So there's ways of drawing it so that you get slightly different lines. So that looks like a decent tangent at 5 seconds, but you could also draw one a little bit off that, like that. So that also looks like a decent tangent. So it's a little bit tricky. It's not an exact type of a question, but what I would suggest is try to look for a line that goes through some handy sort of points on the graph, and that's going to give you an easier time of it. So for this one, maybe starting at this point 3, 0, and then going up like this might give me some nice points. So if I try to find another point on the graph, and I'm not really finding one, but okay, so that kind of goes through this point here, or it also goes through these grid lines here. So I mean, try to sort of wiggle your tangent line around a bit to get it to go through some points on the grid lines. That makes it a little bit easier. Once you've done that, you want to find the gradient of that line. So how do we find the gradient of a line? We want the rise and the run. So that's the reason I'm saying find some points of grid lines, because then it's easier to find the rise and the run. So if I use this point here, or well, this will give me smaller numbers. So let's use this point here. The rise, I've gone from 0 to 60. So just to be clear, we're looking for the gradient, and that's the rise over the run. So the rise, 0 to 60. The run is from 3 to 7, and the scale here is 0.2, I believe. So 1.2, 1.4, yep. So this would be 7.2. So the run is 7.2, subtract 3, the difference between those two, that would be 4.2. So the speed then will be 60 divided by 4.2. So I guess we could get a decibel number for that. 60 divided by 4.2, 14.28 meters per second. Let's round that off to 14.29. 14.29, and that's approximately, and that's in meters per second, because this distance is measured in meters and the time is measured in seconds. You could probably round this off to 14.3 even, so my final answer there, I would round off to 14.3 meters per second. And the mark scheme, I believe, has a range of answers. So check the mark scheme for those. I think it's from 11 to 19. So if you got anywhere between 11 and 19, you would get the correct marks there. So 3 marks. 2 of those marks would be for drawing a tangent line and then finding the rise and the run. And then the other mark would be for an answer in the correct range. Okay, so that's how we're finding the speed of the car at 5 seconds. Here's a bit of a brain teaser for you. What does instantaneous speed actually mean? So what does it mean to pick a point and say that's the speed at that point? What does it mean to have speed in one moment in time? And if you can answer that, you're doing better than anybody else in history. That's a question that nobody seems to be able to answer satisfactorily. What is instantaneous speed? Anyways, moving on to question 15. Question 15 says a darts team is going to play a match on Saturday and on Sunday. The probability that the team will win on Saturday is 0.45. If they win on Saturday, the probability that they win on Sunday is 0.67. If they do not win on Saturday, the probability they will win on Sunday is 0.35. Complete the probability tree diagram. Okay, so we've got some gaps to fill in. Well, if the probability that they win is 0.45, remember probabilities need to add up to 1, so the probability of not winning will be 0.55, 1 take 0.45. The probability that they win on Sunday, if they win, they tell us in the question. If they win on Saturday, the probability they win on Sunday is 0.67, so that can go straight in here. And then the probability that they don't win is 1 take 0.67, that will be 0.33. And then if they do not win on Saturday, that's the other branch of the probability tree diagram down here. They tell us the probability they'll win on Sunday is 0.35, so that goes straight in here, winning on Sunday, 0.35. And then the probability that they will not win on Sunday is 1 take 0.35, which is 0.65. And we're done with our probability tree diagram. Part B says find the probability that the team will win exactly one of the 2 matches. So the probability that they'll win one of the 2 matches, you can also say that's the probability of winning. So I'll write the whole thing out. So that's the probability of winning and then not winning on Sunday. Or we could have not winning on Saturday and winning on Sunday. Okay, so this is winning on Saturday, not winning on Sunday, or not winning on Saturday and winning on Sunday. These are 2 different outcomes, right? It's different if you win on Saturday and lose on Sunday, and that's different to losing on Saturday and winning on Sunday. So these are 2 different probabilities. We need to work out what each of them are and then add them together. So this is how we work with probabilities in a probability tree diagram. And one way to remember this is look at the language. When we say and, we multiply, and when we say or, we add. So that's an arrow there. So and is multiply, or is add. And the reasoning behind this is, well, it's not that deep really, but if you say or, I mean, think about flipping a coin. You can get heads or tails. And we know that those probabilities need to add up to 1. This is 50% or 0.5, tails is 0.5. We can get heads or tails, we want to add them up to get the total probability. So when we say or, it's like we've got 2 possibilities. We just add them together to get the total probability. And then when we're saying and, so we can actually still use this example. When we say and, if we want a heads and a tails, we're doing 2 flips of the coin. It compounds, right? We've got 50% chance, and then a 50% chance of a tails. We've got like 50% chance of 50% chance happening, right? So we've got a half a chance of getting heads, and then half of that again of getting a tails. We multiply. So I have videos going through this in more detail. That's just a brief kind of explanation why we add and multiply. Hopefully that made a little bit of sense. Anyways, so we want the probability of winning and not winning. So we go along this branch here. So the probability of winning and then not winning. And we multiply these two. So we're going to do 0.45 multiplied by 0.35. So this will be 0.45 multiplied by 0.35 plus not winning and then winning. So that's this branch here, not winning and then winning. And we need to multiply those two. So 0.55 multiplied, 0.55 multiplied by 0.35. Okay, and then we just need to plug that into a calculator. Oh, I've written this probability wrong. That was meant to be 0.33, not 0.35. Apologies for that. So that's 0.33. Okay, 0.33. Apologies if you were yelling at me that I got that wrong. So 0.45 times 0.33 plus 0.55 multiplied by 0.35, and I get 0.341. 0.341 or 34.1%. Final answer 0.341. That was question 15 for 5 marks. On to question 16. Question 16, part A says, on the grid, draw the graph of x squared plus y squared equals 12.25. For this type of question, it's really going to help you to recognize immediately that this must be a circle. This is what the equation of a circle looks like. X squared plus y squared equals 12.5. You can also have x take some number, like x take 2 plus y take 3 all squared is equal to some number, whatever it would be. So that is also an equation that can look like a circle, but you can also just have x squared plus y squared. Once you recognize this as a circle, you also need to know how to find the radius. The radius is the square root of this number. So r is going to equal the square root of 12.25. So the square root of 1225, maybe you know that, but of course we can just go to our calculator, 12.25, and we get 3.5 for our radius. So you need to recognize this as a circle and then know how to find the radius of the circle. If we just have x squared and y squared, that means the center of the circle is at 0, 0, the origin, as we call it. So the center is at 0, 0, the radius is 3.5, then you can draw your circle in. So 3.5, that will be, well, here's 3, and the scale is going up by 0.2. That's kind of annoying because then we're going to have 3.5 being here. Okay, fine, I guess. I wish it was on the grid lines, so it's always nice when the points are on the grid lines. Anyways, 3.5 over here is also a radius, and down here, and then over here. Okay, so another way to do this is just to set your compass. You should have a compass in your exam papers. Set your compass to this length and then draw your circle with your compass. I don't have a compass in this software, so I'm just going to try to do this somehow. Oops, that's not going to work. Okay, there's a circle. It's not exactly the right size, but okay, that's good enough, good enough. With your compass, you'll get it more accurate than this. Set it exactly to 3.5 and then just go around with your compass, you'll get your circle. That is approximately what it should look like. Part B says, hence find the estimates for the solutions of the simultaneous equations x squared plus y squared equals 12.25 and 2x plus y equals 1. The way you can read this equation is it's saying for every increase in for every increase in x, we need to increase y by twice as much. Also, you can convert this into gradient intercept form. Maybe you're used to that. So this would be y equal to negative 2x plus 1. Then you can see the y-intercept is positive 1, which is here, and the gradient is negative 2. So for a gradient of negative 2, we go across 1 and down 2. So there would be another point, across 1 and down 2, and you have your straight line. So let's draw that in. Okay, it's going to be something like that. And because my circle is not perfect, I'm not going to get great answers for this, but they should be fairly close to the actual answers. So anyways, this point here is at about 2, -3, and this point up here is at about, if we go down to the x-axis, that's about -1.2, and this point here is at about 3.4 on the y-axis. And as I said, these will be a little bit off because obviously my circle is not very accurate. So I'm just going to give you the answers here from the mark scheme. The answers were 2, -2.9. So that was this point here. That's meant to be at 2, -2.9. So that would be about here. So pretty close with my diagram. And then the other one was -1.2, 3.3. And I believe there's a range for those answers as well. So that was this point here, -1.2, 3.3. Okay, so that was question 16 for a total of 5 marks. Question 17 says the histogram shows information about the times taken by some students to finish a puzzle. Okay, so here's the time taken, and this is the frequency density, as always on a histogram. Part A says complete the frequency table for this information. The first one is done for us, so the time taken between 0 and 5 minutes, we had 4 people in there. For this type of question, you want to know how the frequency density is found. So the frequency density is calculated by taking the frequency, the amount of people for the given interval, and dividing it by the class width. So for this example, between 0 and 5 minutes, to get this frequency density of 0.8, you would do 4 divided by the class width, which is 5 minutes. Okay, so that gives you 0.8. So then we can reverse this to find the frequency. So the frequency is equal to the frequency density multiplied by the class width. So for this second interval from 5 to 15 minutes, we have a class width of 10. 5 to 15 is 10. And we multiply that by the frequency density, which is 0.4. So 10 times 0.4 is 4. So the frequency, the number of, what are we talking about? The number of students who finished the puzzle between 5 and 15 minutes was 4. The second class width is 10 again, and the frequency density for that interval is 0.6, so we're going to do 10 times 0.6, which is 6. The class width for the fourth interval here is 5, 25 to 30 is 5, and we multiply that by the frequency density for the fourth bar here, which is 1. So 5 times 1 is 5, and then 30 to 50, that class width is 20, and the frequency density is 0.2. So 20 times 0.2, that is 4 again. So these are our frequencies: 4, 4, 6, 5, and 4. Part B says find an estimate for the lower quartile of the times taken to finish the puzzle. This is an interesting question because there are actually 2 correct answers here, and I'll go into more detail as to why that is the case towards the end. But to find the lower quartile from a frequency table or a histogram, because we have both in this case, we have the frequency table and the histogram. To find the lower quartile, what we need first is the frequency. So we need to add up these frequencies. So 4 plus 4 plus 6, that's 14, plus 5 is 19, plus 4 is 23. So that's my total frequency of the people doing the puzzle. I can take that number, 23, add 1, and divide by 4. That's going to give me a quarter of the data. Now, why do we add 1? It's because we have discrete data. We're talking about students. They are individual things, and to get a quarter of a group of discrete people or discrete objects, you want to add 1 to it. Just a quick illustration, if I have 5 objects, what's the middle of those 5 objects? It's this place here, but to get that point, I don't do 5 divided by 2. That would give me 2.5. That would be in here somewhere. What I want to get the middle value is 5 plus 1. 5 plus 1 divided by 2, which is 6 divided by 2, which is 3. That gives you the third object. That's the middle object. And that's if we're talking about the median. It's the same if you're talking about the lower quartile. You want to add 1 before dividing by 4 because we're talking about discrete objects. In this case, students. So 23 plus 1 divided by 4 is 24 divided by 4, which is 6. So the 6th student represents the lower quartile. Going back to the frequency table, we want to find the class interval that student belonged to. So in the times 0 to 5 minutes, we had the first 4 students. And if we count up 2 more, we would get in this interval here 5 to 15 minutes. So again, the first 4 students were in this interval, and then add 2 more, we've got the 6th student in this one here, in this interval here. And then we look at the number of students in this class interval. In this interval between 5 and 15, there are 4 students. So then you want to do 6 take 4, or 6 take the number of students before this class interval. So 6 take 4 equals 2. And then you take this frequency and divide by the number of, by this number here. So 4 divided by 2 is 2. Then you take this number and divide the interval by 2. So what is this interval? It's 5 to 15, that's 10 minutes. So we're doing 10 minutes divided by 2, which is 5 minutes. And we add that on to the time, the cumulative time. So the first interval is 5 minutes. We add another 5 minutes. That's the lower quartile. Possibly an easy way to do this is just to use the histogram. So we've got 2 students left over in this interval. So we halve this bar, right? And what time are we at now? We're at 10 minutes, and that's your answer. So however you want to do that, either using the frequency table or the histogram is fine, but you should end up with a final answer of 10 minutes. So just to kind of summarize all of that work I did, firstly, I took the time of the first interval, which was 5 minutes, because that's below the lower quartile. That's included in the lower quartile automatically. Then what I did is took the difference between the total number of students in the lower quartile and the number of students in the first interval. So take 4 and divide it by the number of students in that interval and multiplied it by the width of that class interval. So that was 10 minutes. So you're basically taking a fraction of that interval that you're looking at. And this was a half of 10 basically. So we did 5 plus 5, which was 10 minutes. Okay, that's the first answer. The second answer involves not adding 1 to the frequency. So 23 divided by 4. Why can we do this? Is because we're talking about times. So remember I said we add 1 when we're talking about discrete data. Well, if we're talking about continuous data, we do not have to add 1. So because we have both types of data, we have students, which is discrete, and we have time, which is continuous, we can do either of these approaches. So this is also going to give you a correct answer by not adding 1. So now we do 23 divided by 4, which is 5 3/4, so 5.75. And then you can do the same process. So you can do 5 plus 5.75, take 4 divided by the class interval, or sorry, the frequency in that class interval of 4, and multiply by 10. And for this, well, let's put that into a calculator. So what I'm going to do is just 1.75 divided by 4, multiply that by 10, and I get 4.375 plus 5 is 9.375 minutes. And this was minutes as well. So both of these are correct. Now, if you're confused as to whether we should add 1 and not add 1, well, the mark scheme gives 10 as the most correct. In other words, it gives that as the main answer, but it makes a note that 9.375 minutes is also acceptable. But I wouldn't blame you here for being confused as to whether you should add 1 or not. And as I said, we add 1 when it's discrete data, we do not add 1 when it's continuous, and because we have both types here, you can do both. And I could go into more detail here, but I'll leave that up to you. If you are curious, leave a comment and I can reply in more detail as to what I think is the most correct answer in this case. But there you go, that was question 17 for a total of 4 marks. Question 18 says A, B, C, D, E, F, G, H is the alphabet. No, sorry, it says is a cuboid. Here we go. AB equals 7.3 centimeters. AB. CH equals 8.1 centimeters. Angle BCA equals 48 degrees. Find the size of the angle between AH and the plane ABCD. Give your answer correct to 1 decimal place. Okay, so they haven't marked in these measurements, so let's go ahead and do that first. And you need to think three-dimensionally here. It's a cuboid, so this is a three-dimensional shape. This length AB is at the back of this shape, so that's why we've got the dotted lines there. It's at the back of the cuboid. So 7.3 is the back side of this cuboid. CH is 8.1. That's the front of the cuboid. Angle BCA is 48 degrees. So where's BCA? That's in here. Okay, so that's, oops. Let's see. Okay, so let me, okay, BCA, that's this angle. That's 48 degrees. 48 degrees in there. That's like the bottom of the cuboid, the angle between, or between one edge and the diagonal. Really try to think three-dimensionally for this question. And we're looking for the size of the angle between AH, which is this line, and the plane ABCD, so that's the base of the cuboid. When we say find the size of the angle between AH and the plane ABCD, we can also say this will be the same as the angle between AH and AC, those two lines. That's going to be the same as the angle between AH and that plane. So as long as we can find that angle, we'll be able to answer this question. So you can see this is going to be using trigonometry because we have some right angle triangles here. The first one is down here, this triangle ABC on the base of the cuboid. This will be a right angle, a 90-degree angle because that's the corner of a cuboid. All the faces of a cuboid are rectangles, of course, so that will be 90 degrees, ABC. So that's a right angle triangle, and then this triangle AHC will also be a right triangle. And hopefully that should give us enough information to solve this. So the first thing I'm looking for is the length of AC. Okay, that's going to help me to find this angle, because as long as I can find another length on this triangle AHC, then I can use trigonometry to find that angle, because we already know one side of the triangle, 8.1. And I can do that, as I said, using trigonometry. So for this triangle ABC, down here on the bottom here, we have an angle and a side. So how do we find the hypotenuse? Given an angle and a side, we use sine or cosine. In this case, we have the opposite side of that angle, 48 degrees, and we want the hypotenuse, so you need to think which ratio will you use. Remember, sine of an angle is the opposite side over the hypotenuse. cosine is adjacent over the hypotenuse, and tan is the opposite over adjacent. Okay, so which one are we going to use? We have the opposite side, we need the hypotenuse, we're going to use the sine ratio. So we can start this off by saying sine of 48 is equal to the opposite side, 7.3 divided by our unknown side, AC. And that equation will allow us to find that side. So then we can say AC is going to equal 7.3 divided by sine of 48, and then we can go to our calculators and put in 7.3. Make sure your calculator is in degrees. 7.3 divided by sine of 48, and I get 9.82 approximately. So 9.823, and you can write dot 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 so you don't have to give an approximation. That just shows that the decimals keep on going. So now I have AC. If we're looking at this triangle AHC, then we need to use another trigonometric ratio to find this angle of the angle between AH and the plane. In other words, the angle HAC. So in this case, I'll have this side and the adjacent side. So opposite and adjacent, which ratio should I use? That will be the tan ratio, opposite and adjacent. I have those two sides. And this will give me the angle. So then, using the tan ratio, I can say tan of theta is equal to the opposite side, which was 8.1, this side here. And the adjacent side is AC. We just got an answer for that of 9.82 approximately. And then to find the angle, we want to use the inverse tangent of 8.1 and 9.823. And this will give us our angle. So we'll probably end up rounding this off. So for this, you want to know how to find the inverse function on your calculator. That's the little tan -1 there. And we put in 8.1 divided by our previous answer. Make your life easier by using the answer function on your calculator. And I get 39.508. And it says, give your answer correct to one decimal place. So this will be 39.5, rounding this off. 39.5 degrees for a final answer there. 39.5, that was question 18 for 4 marks. Question 19 says shape S is 1/4 of a solid sphere, center O. The volume of S is 576 pi centimeters cubed. Find the surface area of S. Give your answer correct to 3 significant figures. You must show your working. And here they give us the formulas. Volume of a sphere equals 4/3 pi r cubed, and the surface area of a sphere is 4 pi r squared. Okay, so how can we use these to find the surface area of this shape? Well, it tells us that it is 1/4 of a solid sphere. So the first thing that I notice is this curved area on the outside will be 1/4 of this. So if the surface area of an entire sphere is 4 pi r squared, if we take 1/4, the surface area on the outside here will be 1/4 of that. But hold your horses for a second, because here, surface area of a sphere, 4 pi r squared, what does this require? This requires us to know the radius. And nowhere in this question do they tell us the radius. They tell us the volume. They do not tell us the radius. So we're going to have to figure out the radius first. And we can do that using this piece of information. The volume of S is 576. And the volume of the sphere is 4/3 pi r cubed. So what we can say there is that 576 pi is equal to 1/4 of the volume of a sphere. So 1/4 of 4/3 pi r cubed. Okay, so here if we multiply these out, those 4's will cancel out. So then we can say that we'll have 1/3 pi r cubed equal to 576 pi. Then we're trying to solve for r, so we're trying to get rid of everything but r and some number. We could also cancel the pi's if we divide by pi, and then multiply by 3. So 576 multiplied by 3. Let's go to the calculator for that one. 576 times 3, I get 1728. And then r is going to be the cube root of that. So try to find your cubed root function on your calculator. Take the cube root of that answer, and I get 12. Okay, there you go. So r is equal to 12 centimeters. And now we can go ahead and work out the surface area. So as we were saying, the curved surface on the outside is going to be a quarter of the surface area of a sphere. So it's just going to be pi r squared. Also, on the inside, because if we're looking for the surface area, we want the total surface area. So we have to consider these faces as well. On the inside, we actually have an entire circle, right? We have half a circle here. So let me use different colors. We have half a circle here, and then we have half a circle here. So on the inside of this quarter sphere, we have a circle. On the outside, the curved surface we said was pi r squared. That's effectively the area of the circle as well. So the total surface area then is going to be basically 2 lots of a circle with a radius of 12. So we can say the surface area is equal to 2 pi r squared. So 2 pi times 12 squared is 144. 2 times 144, that's 288 pi. And we can leave the pi as is. Oh, actually, sorry, it says give your answer correct to 3 significant figures. We do not leave it like this. We want to get a decimal answer with that. So let's do 288 multiplied by pi, and I get 904.778 to 3 significant figures. 904 are the first 3 significant figures, and look at the next number, that's a 7. That means I need to round that 4 up by 1. So this is going to round off to 904 centimeters squared. And that's our final answer there. So final answer, 905 centimeters squared. And that was question 19 for 5 marks. On to question 20. We're almost at the end. 2 more questions to go. Martin did this question. Rationalize the denominator of 14 over 2 plus root 3. Here is how he answered the question. Okay, so we multiplied by 2 negative root 3. That's fine. And then he expanded those out. The numerator looks okay there. And we've got 4 plus and minus and a 3. Oh, this looks like a problem, doesn't it? Positive 3. And then, okay, so I think that's the issue there. Anyways, the question said Martin's answer is wrong. Find Martin's mistake. The positive 3, that should be a negative 3, because a positive times a negative makes a negative. So what could we say? We could say the positive 3 on second line should be negative 3. So we found the mistake. You could also, I guess, probably circle it. Second part of this question says, Cyan did this question. Rationalize the denominator of 5 on root 12. Here is how she answered the question. 5 times root 12 on root 12 times root 12. Okay. Oh, I'm not sure what she's done here. So what's happened here? She's tried to simplify this surd. So root 12, you could write this as root 4 times root 3, which you could change to 2 root 3. But she's, I think, done it the other way around. She said 3 root 2. Okay, so there's the error, I think. So for that one, we could say something, you could circle it and then say something like root 12 equals 2 root 3, not 3 root 2. Okay, so that was question 20 for 2 marks. On to the final one. Question 21 says Jackson is trying to find the density in grams per centimeters cubed of a block of wood. The block of wood is in the shape of a cuboid. He measures the length as 13.2 centimeters, correct to the nearest millimeter, the width as 16 centimeters, correct to the nearest millimeter, and the height as 21.7 centimeters, correct to the nearest millimeter. He measures the mass as 1,970 grams, correct to the nearest 5 grams. By considering bounds, work out the density of the wood, give your answer to a suitable degree of accuracy. You must show all your working and give a reason for your final answer. What this is going to involve is finding the lower and upper bounds for all of these, and then finding the lower and upper bound for the density, and then finding a suitable degree of accuracy. So firstly, let's start off by finding the lower and upper bounds for all of these measurements. And I'll show you a little trick as to how to do this. So the first thing I'm going to do is actually write these in millimeters. So the length I have as 13.2 centimeters is 132 millimeters. The reason I'm doing this is because they've rounded to the nearest 1 millimeter. Well, they say nearest millimeter, but that's the same as 1 millimeter, right? So the little trick is when whatever you're rounding to, take that thing that you're rounding to the nearest of, so 1 millimeter, take a half of that and then add it and subtract it. As long as it's in the same units, this will always work. So if it's 132 millimeters, add 0.5 to get the upper bound and subtract 0.5 to get the lower bound. So the lower bound is going to be 131.5 millimeters and the upper bound is going to be 132.5 millimeters. And we're done for the length. The width in millimeters is 160. So the lower bound is 160 take 0.5, which is 159.5. And the upper bound is 160.5. And by the way, the lower bound is always less than or equals to because we round that up, but the upper bound is always just less than because 160.5 would actually round up, so we only round down everything less than that. We don't round down 160.5, so that's why it's less than, not less than or equals to. And that's always the case for these error intervals. And the height, let's finish off, the height is 217 millimeters. Again, take 0.5, add 0.5, and we have our lower and upper bounds. So there we go, 217.5 for the upper bound. Okay, then the mass is 1,970. This is rounded to the nearest 5 grams. Take a half of that, add it and subtract it, and you have your bounds. So 2.5 is a half of 5. Subtract that, we get a 1965.5. This is for the mass. And the upper bound is 1972.5. And they are your bounds, and we're done for those. Now we need to know how to calculate the density. The density is the mass divided by the volume, the weight divided by how much space it takes up. And to get the upper bound for the density, we're going to do the largest possible mass divided by the smallest volume, right? That's going to give you your largest possible density here. So the largest mass, the upper bound of the mass is 1972.5. Oops, 0.5. And the smallest volume will be, well, how do you find the volume of a cuboid? Let's just make a little note up here. The volume of a cuboid, remember what a cuboid is? That's like well, think of a block of wood. What shape is a block of wood in? You would know this already, right? It's like a three-dimensional box. Okay, so that's meant to be three-dimensional. That's what a block of wood would look like. We have our height, we have our width, and we have our length. The volume is those three things multiplied together. So how do we get our smallest possible volume? We would multiply the lower bounds. So we're taking all of these values here and we're multiplying them together. and because we want the volume in grams per centimeters cubed, I'm going to convert these back to centimeters. So instead of writing these as millimeters, I will do centimeters here. Now you didn't have to convert these to millimeters. I just did that because I find it easier, but you could have left these as centimeters as well, and that would be perfectly fine. So converting them back to centimeters, I just move that decimal place over again, and that will give me the lower bound of the volume. The upper bound of the mass, this will give me the upper bound of the density. Just to make it a little note, we've done the largest mass divided by the smallest volume. Okay, so putting this into a calculator. Let's go ahead and do that. Shout out to calculators, making our lives so much easier. Thinking back to the 1960s, you would have had to do all of this by hand. Wouldn't be too fun. So I've put all of that in, and I get an answer of 0.43438 and so on. I might write down the first 6, 0.434382, 0.434382, and I put 3 dots there to show that it's continuing on. Okay, now I want the lower bound of the density. This is going to be the smallest mass, the lower bound of the mass, divided by the upper bound of the volume. So taking all of the upper bounds and multiplying those together. Again, in centimeters, this would be 13.25 multiplied by 16.05 multiplied by 21.75. And again, just to make a little note, this is the smallest mass divided by the largest volume to get the lower bound of the density. Okay, putting that into a calculator, 1967.5 divided by all of this, 16.05 multiplied by 21.75, and I get an answer of 0.425367, and 3 dots to show that continues on. Okay, so we've done all of this work, but we still haven't quite finished, because remember it says give your answer to a suitable degree of accuracy. What this means is both of your bounds need to round off to the same thing. So for example, if I rounded this off to 3 decimal places, this would be 0.434. If I rounded this one off to 3 decimal places, this would be 0.425. So you can see to 3 decimal places we get different answers for the upper and lower bounds. But if we round to 2 decimal places, if I round this to 2 decimal places, I get 0.43, right? 0.43 because the next number is a 4, so that stays the same. And for the lower bound, if I round this off to 2 decimal places, I get 0.43 as well because this rounds up. That's a 5 there. Therefore, 2 decimal places is a suitable degree of accuracy because we get the same answer for both. And that's what you're looking for. You want to round off to the number that gives you the same answer for the upper and lower bounds. So we can say then that the density is equal to 0.43 grams per centimeters cubed to 2 decimal places. And I believe it also says give a reason for your final answer. So that let's just say then that's because to 2 decimal places the bounds are equal. Okay, so that's why I rounded off to 2 decimal places. That's why it's a suitable degree of accuracy. And that was question 21 for 5 marks. Final answer of 0.43. And that's the end of the paper. I hope you found this video useful. Please leave a like if you did, subscribe if you want to see more content, and I will see you in the next one. Bye for now.